Could you check, Ben, if the recording is still...
Just started now.
Oh,
Thank you, Debbie.
yeah, thank you.
Thank you for joining for this next session, which we're going to talk about the changes we're doing in Semantic AI in Tridion Sites 10. So my name is Ben Middleton. I'm an architect working on the Tridion platform. So today I really want to talk about how we can take what we've already built in Semantic AI in Tridion Sites 9.6 and improve upon it for the recommendations requirement. And this is something that's quite apt at the moment, with a lot of people talking about generative AI and the facilities that are available there. So what are recommendations? Essentially, answer that question, find me other content or show me other content that's like this. So imagine you have a set of content and you've tagged it up using the semantic features that we had already in Tridion Sites 9.6. It's really building upon that reliable knowledge, and that's a key thing here, because a lot of the current talk of generative AI is around using the body, the text, to determine what it's about. And there's some questions about, how reliable is that? In our case, we've already put the investment into using content editors and knowledge managers to tag their content effectively, using some of the features of taxonomy space, which is supported by Pool Party, which has its own AI underneath. And based upon that, we're building up a body of content that we know has good quality tags associated with it. So our content recommendations is very much based upon the fact that we have this well-tagged set of content, and how do we then expose that to end users. So what we've done, we've extended our existing content search API, which was built back in previous releases of the DXD component, and we've added in the facility to do content recommendations. So this provides various ways of doing this, but first way is just giving it a really simple case. You give it an existing document, and what it does, it builds a footprint of that document, which is based upon the tags, those concepts associated with that document. And then it uses those tags to find other content based upon some parameters that you configure the recommendation query with. And then using sort of most frequent term and term-based frequency filtering at the back end, it comes back with matching content, whether that's pages or components, to that footprint. And then you can use that to drive functionality in your web application, be it a sort of related links page or a way of drilling down further into relevant content for you. So as I said before, we're using the tags that we've already applied to our content within taxonomy space, which is using that Pool Party Semantic AI index. If you're familiar with that, we have this concept of a facet or a concept scheme. And within each of them, there's a sort of hierarchy of concepts, and you can tag a single item of content across multiple concept schemes. So you can have different facets, multiple facets for your content. And then we can use each of those facets, and you can build your recommendation based upon either the concepts that were attached to that original document or based upon some tuning. And you'll see that in a demo that I'll show shortly. We provide the full filtering of the results as well. So we already have a very rich search API within the public content API. And what the mechanism does is we now apply recommendations first. That gives you a list, an ordered list by score of matching content, and then you can filter that list using those standard search criteria. And that includes all the other features we added in previous releases. So that includes things like document facets. You can have the document summaries based upon that filtered list. And you can also use all the semantic content modeling that we've provided in previous releases as well. So what does that look like? So very briefly speaking, you can see what we've added is this recommendation query here. This is a really simple case where we're passing in a single item, existing item, and then the rest of this query is as it was before. So we've got a standard criteria here saying just show me those that sit within this namespace. So if you're a customer that has both sites and docs, you might want to filter those results. And then there's the full power of GraphQL below that, and we'll see more of that in a minute. So just briefly on the architecture of how this is all wired up. So we have taxonomy space, as we call it, which is the pool party user interface. In Tridion sites, we have the taxonomy connector, which is exposed to the connector framework, and that sits within both the content manager and within our deployer service. So they both use the same connector, which is deployed through the add-on. So we actually have the add-on service sitting next to this as well. And then editors have sort of two roles, really. The first is, well, the first role is actually your knowledge manager, if you have an individual role where they will create or maintain or buy and tweak a taxonomy of some kind. These days you can actually build them quite quickly on the fly as well using AI if you wish. You just want a starting point, and then you can tailor it for your particular domain needs. So they're responsible for making sure they've got a good quality taxonomy there. Then it's the editors can make use of that taxonomy when they're editing their content within Experience Space, and they will have full access to the configured concept schemes or facets and the concepts contained within them. They can get suggestions as well, so it has a facility to suggest contents, and you can do the batch tagging as well that we've seen in previous releases, so you can process multiple items at once to do a quick kind of filling in of your content with concepts, and then you can go in and refine it and give it that good quality that we were talking about earlier. From there, obviously the content manager will publish that out to our system, and what the deployer will do is it will look at that incoming content. If it's not seen that facet before, the first thing it goes off and does is actually pull down from taxonomy space, the pool party index. It pulls down a full copy of that hierarchy for that facet and stores it within a new index that we have within OpenSearch. So essentially, we've then got a full copy of the links between concepts and all the kind of language relations and various labels and things like that. So we don't, at no point do we have to go back to taxonomy space. We then have it all at this point. So the deployer populates that there. It's all done by reference. So you see here that we reference the IDs of the concepts, not the values, and the value of that means that if you then later change your taxonomy, or if you need to change the labels on that thing, you don't have to republish content. All you need to do is resync your taxonomy with our OpenSearch taxonomy index, and then they become visible to your web app. So that's the responsibility of the deployer here. Obviously, it's putting the content as well into our broker database. And finally, the content service is where we now expose the facilities on top of these indexes, where we previously had faceted search, and we've added in the recommendations piece here. And then from a customer web application perspective, they can build all of these kind of features using this functionality. One thing I have added to this diagram is the use of the API gateway. So this is something we would use in our own cloud. There's increasing demand for headless solutions, and there was a reference to it earlier in the chat. Clearly, if you want to expose an endpoint to the public internet without any interim web application sitting there, then you need some checks and balances in place. So this is where we would advise you have an API gateway of some kind, which provides things like firewall, metrics, security, denial of service, and authorization, because clearly you don't want to be sharing tokens publicly in your web application to get access to the content service. So in our own cloud, we have a gateway that does all of these for you, and it means that we can then provide a level of control of what's actually hitting that content service. If you still wish to have a web application for some kind, you may still choose to use the GraphQL endpoint to a web application. That's a very common use case as well with customers. And in that case, the gateway would then not be needed because you would have that control within your web application indeed. Okay, so I'm going to jump over now to a quick demo of this behavior. So I'll start off with the backend piece. So You can see here, this is our taxonomy space. So this is showing what you can see in Pool Party. I'm just showing you 2 examples here. So this is a particular project we've built, has 2 facets within it, or concept schemes, cocktails and ingredients. And then there's a series of hierarchical concepts below these, and you can obviously drill down into these. You can see this is a hierarchical structure of taxonomies. Then jumping over to experience space, I've published a few sample components here just to show you the sort of content we've got. So I've actually, for this demonstration, I can show you a new one if we were to add a new example here. So let's say you can give it some concepts here. So again, it's got a look ahead. I can navigate this tree, or I can just choose things from the tree. So I've created a few sample ones here. You can see how we've added the content to that. I'll just publish that so that it's available for our next part of the demo. In the meantime, so I'm going to be using the GraphQL client to show the samples that I'm going to test today. So Insomnia is one of many GraphQL clients. The beauty of GraphQL is it has an introspection endpoint, so you can just point a client at it and it will build up your query for you, your schema for you. So simple example here, this is pulling out the taxonomy that we store within OpenSearch that I was talking about. This is that whole taxonomy as we store it within that index and how we can expose it through GraphQL. So this might be used if you're building a navigation device that you want to use for these facets. More typically, you might incorporate it with some search capabilities. So just a really simple search query to begin with before I delve into the recommendations. So this is just showing again a simple example of our search, how to use it. So this has a basic criteria in it. So the first thing is I have a namespace that we constrain our results with, because I might have some Tridion docs content in this index as well. And then in this case, I want to just show content that has cocktail in the names, because if you recall that previous screen, I've just created some content with the name cocktail in there. So this, you can see, is pulling back those 8 hits, those 8 cocktail samples that we had here. And in the results, you can see at the bottom, I'm including this concept schemes property, which means you can see on each of these matching nodes, you can see the matching concept schemes associated with it. So you can see the labels. You recall I said we reference by ID, so you can see the actual ID that we store when we index these things within DXD. So this is consistent from what's coming out of Tridion sites CM and what we end up with in the deployer. It's a really simple example there. So of these 8, what can we do? So first up, what we're interested in is using a really simple example. So we're going to use this existing document, which is in this case that ABC cocktail that I built earlier, which has these 3 concepts associated with it on the index, sorry, on the ingredients facet. So you'll see that comes back. Really simple on this. Obviously, we're only going to find matches that have one of those components in there. So this isn't doing anything too exciting at this stage. So obviously we're matching coconut milk in there, and we're matching blackberry because we've got that one in there. So it's just coming back with those 3 hits. I've got this duplicate one here, which is relevant in a minute. What's interesting to note here is the score. So this score is the score that OpenSearch calculates for us based upon these queries that we're generating. So this is based on relevance. So the further away or the less relevant this context is, obviously the score will be lower. Now, what's useful about that is you can actually boost these scores. So in and of themselves, this is the same query, just with a boost of 100 on it. So you can see that one we had back here is just multiplied it by 100. So you can see what the boost operator is actually doing to the scores here. So in this case, it's probably not that useful because you're still getting the same order back and the relevance isn't any different. Where it is useful, though, is if you start to incorporate multiple concept schemes within this. So if you've got a couple of facets, for instance, you might think that, well, actually, you think this facet's more relevant from a perspective of a recommendation than this one. So in which case you might increase the boost on that one. And then you'll see the results coming back. Suddenly this one, which is less relevant if you were just looking at the concepts as they were, but much more relevant now because we've boosted this score on this, and we're only matching this based upon this different concept scheme, which is this cocktails one. So this is where the boosting comes into play, because you can then tailor and tune the results of your query based upon your data structure. Next up after that, I want to talk about the broaden by query. So you saw before that we were looking at just the immediate hierarchy of those concepts at that level, but clearly we have a taxonomy hierarchy, and you might actually want to broaden your scope of your recommendations. So when we talk about broadening here, we're talking about, if you like, walking up the tree and then kind of going down to the leaves from below that. So if you broaden by 1, you'll obviously go 1 layer up. If you broaden by 2, you jump 2 layers up. So in this example here, we're jumping up 2 layers up the tree, still using, in this case, we're using a specific concept. So this is previously we were using a specific existing ID, so we were building that footprint from this document. In this case, we know up front that we only care about this particular concept to determine your recommendations, and in which case it just uses that as a starting point, and then we want to say broaden up from that point. So it'll walk up the tree, and then it will kind of traverse back down again. It will find those matching items of content that match those queries. So you'll see we started off with dark rum here. So clearly we'll match dark rum, but you should also see other alcoholic beverages in this case that sit either 1 or 2 levels up. And you can see it in the ingredients here. So we're only broadening this specific concept scheme at the moment. So I'm not looking at the cocktails one, I'm only looking at the ingredients, but you can see that all the way down here. These are all being matched to that broadened thing. But again, the further away you get from our starting point, the lower the score. So again, those closest to the top will have the highest score, and those, as you begin to fall down the tree, will start getting lower scores again. So they're the kind of the 2 key pieces of our recommendation tailoring thing, and between those 2 you can build quite nice sort of recommendation queries for building up those sort of more like this features on your web application. As I said before, you can include other features in here. So as you've seen, we have this criteria here. You can add other criteria to that if you wish, and you can also include those facet summaries that we introduced in the previous release, which basically give you summaries of the results. So in this case, you're getting the facet summaries of this recommendation queries. So if I hide the facets, so you can see there are 5 hits here, and then you're just getting the summaries of those 5 in there. So again, that's a nice navigation device if you wish to use recommendations to drive a navigation device and then show a sort of a faceted breakdown, perhaps in your left-hand navigation or search device within your web application. This is a good way of using this because you can see those counts as well, and you can just further drill down using the results from this and then plugging them back into either the recommendation query or as a filter on the criteria itself, which is how we would have done it if you weren't using recommendations. And then finally, I want to talk briefly on the content model piece. So if you recall, our search queries allow you to hook onto the broker database as well. So if you're just accessing these part of your results, you're not touching the broker, you're only going to OpenSearch to get those results. If you need some of the features from the broker, you can include the broker parameters in the source query, and that will then come back in that second piece. So if you had a semantic model built up, and if you've seen some of our previous sessions in the Science 9.6 release, we've built a whole new semantic content model feature where you can expose models within this. These would then be available within this section here. In this case, I've only published components, but if this was a news article or a press release, you would then get all the richness of those properties within that in these results. And the nice thing about that is it means you don't then have to do another round trip to the broker as a separate query. You can just do it all within your single search query and get everything back that you need in one hit. Okay, so that was going to be it for this session today. I will leave this open, perhaps stop recording, but I will leave it open in case there's any questions.